Now we take a look at the 1,4 addition of alcohols. We're going to keep this one pretty brief because it turns out this is not a very commonly used reaction. But just as we've seen with other nucleophiles, if our carbonyl, our aldehyde or ketone, is conjugated, and if our nucleophile can function as a leaving group, which something like methanol or typical alcohol certainly can, then we will get a preference for 1,4 addition. Now, this reaction is typically done under acidic conditions. Under basic conditions, if you tried to make the oxygen anion, things like methoxide are also strong bases, and you run into problems with potentially deprotonating the carbon adjacent to the carbonyl. So typical alcohol additions, whether it's 1,2 or 1,4, are done under acidic conditions. And we know that's going to start with protonation of the carbonyl. Then our nucleophile, which we'll use isopropanol in this case as our nucleophile, will attack 1,4. We get the shifting of the pi electrons up onto oxygen. We get a deprotonation of the oxygen. And then the enol, or the alcohol attached to the carbon-carbon double bond, will add its electrons back in. We pick up a proton from water. And finally, we lose a proton to form the product. Again, not a highly used reaction, especially in comparison to the 1,2 addition. But we can get 1,4 addition of an alcohol. It does work, and again, under acidic conditions, this is our mechanism.